Welcome to another 1 minute solutions. This will be an interesting quadratic problem in the context of area and perimeter of a rectangle. This is number 21 on the 2020 PSAT exam. And I would agree this is level difficult. Okay, this one, actually, we might have to solve in a little over 1 minute, but I'll teach you how to think through it because otherwise I feel like most students will get stuck. Okay, this says the lengths of the sides of a rectangle are A and B, where A is greater than B. The sum of the lengths of the two shortest sides and one of the longest sides of the rectangle is 36. What value of A maximizes the area of the rectangle? Okay, so most people might be able to get that. Oh, let's write an equation for the sum of the lengths of the two shortest sides and one of the longest sides is 36. So B is the shortest side, right? So it'll be like 2B plus A is 36. And then that's good as a starting point. But we're trying to find A, or the maximum value of A. So we need another equation. How in the world do we get another equation? That's the problem. And then we get stuck, and then we skip this problem and maybe come back to it. Maybe we guess if we run out of time. But here is how we think through it. Okay, so remember I said this problem has to do with a quadratic. How in the world has this have to do with a quadratic? And what concept are they trying to test us here? If you know calculus, you can actually solve this with calculus as well, but actually you don't need it. And using the calculus method might actually be a little more time consuming than what they expect from you here, what I think they expect from you. So we got to understand the concept recall the concept of what is the vertex of a parabola. It's the maximum or the minimum. Let's recall this first. The vertex is the point of symmetry, if I remember, for parabolas and for like absolute value functions. Remember that? It's also the max or the min for parabolas. Okay? So let's recall equations of parabolas in different forms. In standard form, you might remember this, especially if you use the quadratic formula, y equals ax squared plus bx plus c. Okay? You might have also learned vertex form. You should have also learned vertex form, I should say, where it's a times x minus h squared plus k, hk is the vertex. Okay? So how do we get from standard form to vertex form? You can complete the square. That's a big application of completing the square that you might have learned. There's also a quick way to get the coordinate where from the standard form. The x coordinate is x is negative b over 2a. Okay, and to get the y coordinate, you just plug in this x coordinate that you found into the equation back to get the y. Okay, why did I go through all this? So as I was saying, most people could probably translate that second sentence to an equation, 2b plus a is 36. But we need a second equation to be able to possibly find a. And it's asking for area. So maybe let's write an equation for area. Okay, let's call area y. Let's just call it y. Area is length times width for a rectangle, right? Or base times height. The two dimensions basically multiply to each other, which are a and b. So y equals a times b. We're trying to maximize area. Okay, so if we can, y is the area. We wrote this model here. Y is the area. So if we can get y to have a max, like in a parabola, there's a maximum at the vertex, then we're in good standing. So let's use the second equation, this equation that we first found, actually. This is the second equation we wrote, the one that we found from the second sentence to help us out. We can rewrite this as b equals 36 minus a over 2, which we can simplify to 18 minus half a. Why do we want to do that? Well, we can change this y equals ab. This is two variables into one variable now with this equation. B equals this. We plug in this into this equation. Now look, it's a quadratic. If we graph it, it's a parabola. Okay? And we know that there is a maximum because this parabola, this term over here, minus half, is negative, which means it opens downward, meaning there's a max. We're in good shape. Okay? So how do we get the maximum? Negative b over 2a. if it's in standard form. We have it in standard form right here. So don't confuse that A with this A. Imagine this is X, okay? So that's what I'm saying over here. Negative B over 2A. So if we do that, this is the standard form, right? So minus 18 over 2 times minus half. There's half and there's 2. They cancel. These two negatives make a positive. So 18. And that's one of the choices, C. We found the value of A or X. X is the independent variable. A is the independent variable here. So again, yep, sorry, I think that's some audio issues. Um, what was I saying? I was trying to recap. Okay, so the way to think of this is you can get this equation, hopefully not that hard. However, the problem is we're trying to find A. We need some other equation. So take the pieces of information from this problem. Something to do with area. So maybe let's write that. And then maybe after a few more seconds, hopefully not too long, you can piece together that you can rewrite this as an equation of one variable, and it's a quadratic, which we know the vertex is the max min, and we know that this particular parabola has a max. So that answers the question. And so we got to critically think and put the pieces together to get to the final answer. Otherwise, you'll just be stuck with this one equation and you won't get anywhere, all right? And this is how this problem, strangely, gets you to apply the concept of a vertex.